So if you're looking at problem number func_20 in the class assignments, it asks you to apply the principle of composition to solve this problem. And composition just means that you have a function that calls another function, right? So like we have main, and then main might call a function called like find angle. So then it'll go to find angle, and then in find angle you'll run another function called like maybe determine hypotenuse, right? So then it'll go to determine hypotenuse, and then when that function ends, it'll come back to find angle, and then when find angle ends, it'll come back to main, and then when main ends, it'll go back to the function call for main, and it'll end your program. So yeah, so that's what you got to do when you're solving this problem. But the solution to this problem is a little bit tricky, especially if you're just taking geometry or even haven't even taken geometry. So what we have is we have this triangle here, and we're given, or you ask the user for A and B, the two legs of the triangle, and these are called the legs of the triangle, and then this long part is the hypotenuse. So we'll name the hypotenuse C, capital A, capital B, and then the angle inside is lowercase b, lowercase a. So the problem's asking you to figure out the angle B and angle A given the leg A and leg B. Okay, so how we're going to do that is we're going to apply the law of sines, and this law of sines states that the sine of angle A over the leg A is equal to the sine of angle C over the leg C, and so that works for any of these guys, right? So this right angle here is the angle C. So, and this is angle A, and you have the opposite leg is the what's going to be used here in the ratio. So yeah, so then the first thing you want to do is you want to figure out C, and so we're going to use Pythagorean theorem to figure out what C is, right? And then once we have C, then in this equation here, we have pretty much everything we need, right? Because we have the capital A leg, we have the C leg, or C hypotenuse, we have the angle C, which is 90, and so we just need to figure out this last variable, the angle A. So that brings us down to here. And then yeah, so then what we can do is we can multiply both sides of the equation by capital A, and that gives us sine angle A is equal to capital A times sine C, lowercase c, angle C, over capital C, right, the leg C, or hypotenuse. And then when we have that, well, to figure out what, so on the right side of the equation, all of these variables are known, right? So then this was given by the user, this was the 90, right, because it's 90 degrees, and this here we just calculated using Pythagorean theorem. So then the way we're going to figure out the angle A is the angle A is equal to the inverse sine of that expression. Okay, so now it's like, okay, well, how do I do inverse sine? Well, in Python we have a sine, that's arc sine, which is the inverse sine. So what you need to do is put this expression here inside as an argument for a sine. And a sine is a math function, so you'd have to say math.a sine, and then a sine returns the answer in radians, and we don't want radians, we want the angle in degrees. So then you need to put it inside of math.degrees, and then this whole expression here will return the angles, right? The degrees of angle A. And so if you know the degrees of angle A, then you can figure out the degree of angle B, because another law is that the angles, the interior angles of any triangle add up to 180 degrees. So then we know that's 90, and we know that, right? That's given, or we calculated that. So then to figure out B, we just need to add these two together and then subtract that value from 180, and that will give you the B angle. So this is like seemed like a really simple problem, but when you get into it, it's kind of multi-step, and there's ample opportunities to create new functions that do different jobs and apply the principle of composition, right? So yeah, good luck with that.